In the following slides, we're going to take a look at the first Tiny College ERD segment from our reference book. In this ER diagram, we can see that we are capturing the relationship between the professor and school as dean. So you can see the professor can be a dean of one school, at most one school, but they can also be not a dean, where if they are just a professor. Whereas a school, going to the professor, we know that a school must have a dean that is a professor. So we have a mandatory one-to-one relationship between the professor and the school. Between the school and professor. Now, between the school and department, the school might have different departments. So you can see that you have a one-to-many relationship between the school going to the department. But if you have a department, of course, you only have one school associated with you. Now, take note, it is important to take note here that if we have a one-to-many relationship, we usually capture the foreign key in the many part. So in this case, between the school and department, we have captured the primary key of the school entity, which is school code, and place it as a foreign key in our department table. Next, we have the relationship between department and course. You can see here that from department going to the course, it is optional, but it can also be many. Of course, if you have a department, you can offer many courses, but it can also be the case wherein you're not offering any courses. Like, for example, if you are in the human resource department or the accounting department, you are a department in the tiny college, but you are not offering any courses. That is why it is optional. It is possible to not offer any course for a certain department. Now, going from the course to the department, you can see that we have a mandatory one relationship, because if you have a course, you are going to have a department that is offering that. And also, capturing the one-to-many relationship, we can see that the department code is a foreign key in the course entity because it is on the many part. Next is the semester, class, and course entities. In a semester, we can offer many classes, but it's also possible to not offer any classes. Like, for example, at least in other universities, they have summer terms. So it's possible that a certain semester we are not offering any classes. But if you're offering a class, it should be included in a certain or particular semester. And since we have a one-to-many relationship between semester and class, the primary key in the semester, which is semester code, is captured as a foreign key in our class entity. Now, between course and class, there is a one-to-many relationship as well, but is optional because, as we have said, it is also possible that in a certain semester, certain course is not being offered. Like last term, we are not offering IT 131-8. Now, from class going to the course, you will see that if you have a class, you should be associated with a course and only one course. And since we have a one-to-many relationship as well, the primary key in the course, which is course code, is captured as a foreign key in your class entity. We can also have multiple relationships between two entities, just like in this example. The two entities are professor and department, and the first relationship between them are employability. So a department can employ many professors, but a certain professor can only be employed by one department. So it's not allowed to be included in two different departments. And another relationship would be the chair, being the chair of the department. So that one is one-to-one. From department going to professor, of course, it's going to require at least one chair. But from professor going to the department, a professor may or may not be the chair of the department. If they are just a regular faculty or regular professor, then they will be zero. That will be optional. Next is between professor and classes. A professor can teach many classes, but they can also opt not to teach if they are, for example, a research professor. But for a class, they should be an assigned professor for them. Now, this particular example we have already seen in the previous slides, but the only difference with this one is we have cardinality. You can notice from the student going to enroll, we have cardinality 0, 6. The cardinality means that if you are a student, how many enrollments are associated with one instance of a student. And in this case, there can be zero enrollment if they are not enrolled or they do not want to enroll, or at most 6 enrollments. So a student is allowed to have at most 6 enrollments. That's what the cardinality is for. You are asking if one occurrence of an entity, how many occurrence of the other entity is associated with that one occurrence. And going from the class to the enrollment, you can see that the class, how many enrollments can they have? They can have 0 enrollments, but at most 35 enrollments. So for each instance of the class, you can have either 0 or at most 35 enrollments. That's how you determine if you have a cardinality. And you specify the cardinality on the part where it captures. So it's 0 to 6 because it's optional, and the many part is at most 6. In the other hand, on the other side, 0, 35 meaning it's optional, it can be 0, but if it is not optional, it can have at most 35 instances of enrollment. Next, we have department and student. A department can have many or 0 students at all if they are non-teaching department, like as we have said, admissions office or human resources department. But a student can also be part of a department or not. And the part where they are not part of a department might be if they are delinquent or has just been excluded from the program. Next is student advising, wherein you have a professor that can advise 0 or many students, and a student can have only one advisor. We have a one-to-many relationship again. That's why we have a foreign key captured in the student table, the professor number, which is the primary key in the professor table. Next is the room assignment in the buildings for the classes. You can see that the building can have many rooms or no rooms at all. And for each of the room, they can have many classes or none. And for each class, they are associated with a single room. In developing an entity relationship diagram, we need to identify the business rules and translate them into the entities, relationship, connectivity, and entity that we are going to implement in our model. So everything that we have discussed in the previous slides are captured and summarized in this table. This one is a continuation of the table in the previous slide. Now let us talk about some database design challenges. First, we have conflicting goals. Database designers must often make design compromises that are triggered by conflicting goals. For example, database design must conform to the design standards, or you may have high processing speed that may limit the number and complexity of logically desirable relationships, or maximum information generation may lead to loss of clean design structures and high transaction speed. Here we have an example of conflicting goals, wherein we have two implementation of the same concept. We have talked about the recursive relationship of employee table with itself that captures the spouse of the employee. If you are going to implement them within one table, you might have employee number and employee spouse, which is capturing the primary key or the employee number of their spouses. In the second implementation, you can also create a separate entity wherein the separate entity would capture the marriage between the two employees. So it would depend on the requirements that you have. The problem with the first implementation is that you are going to have a lot of nulls, especially for those employees who are single and whose husband or wife is not an employee of the same company. Whereas in the second implementation, this one is more neat, but again, it will be depending on how we're going to implement this based on the design goals that we have in our database. Another implementation might be having two entities instead of one, and in this case, we are just having an extra entity to capture the marriage date in another entity. And as you can see, as we have said, when we have design conflicting goals, we have to assess which one would work best in the goals that we have in designing our database. And that's it. To summarize, we have discussed all about entities and the attributes, and even talk about multivariate attributes and how we're going to deal with them. We have also talked about the relationship degree and close our discussion with the database design challenges.